All right, guys, we are doing inverse trig functions today, and this is kind of a theoretical idea, but at the same time, it's very easy to just find the answers using a unit circle. So if you grab a couple colored pencils or pens, we're going to do an activity that'll help us make this a very easy lesson. All right, before I get started, and this is really an idea that's going to carry over into chapter 5, but there's a big difference between the sine of 30 and where is the sine 1/2. Now, if you look at a unit circle, the sine at 30 is 1/2. The difference is there's only one answer, okay? The sine at 30 is 1/2, period. But this says what angle has a sine of 1/2. And so here theta has infinite answers. You could say it's at 30 degrees, but it's also every 360 after that. So every multiple of 360 could be added on. The other place that sine is 1/2 is at 150. And you could say every 360 multiple 360 added onto that. Or you could even say it in radians. You could say pi over 6 or 5 pi over 6. And if you said either of those, you'd have to add 2 pi n. All right, I don't know why I wrote that there. It's all messy. So there's infinite answers for this, but only one answer to this, okay? Now, because of that, we're going to eventually work on the equations where there are infinite answers, but we want to talk about what's called the inverse sine today. So it's either written like this, or it is also written like this. I don't really know why. It says it somewhere, maybe on the next slide it says why it can be called this, but they used to always call it arc sine. Now they write it like this, inverse sine. Same thing. But this is a sine function, okay? The sine function goes on forever. And if you will recall, in order for a function to have an inverse that is also a function, it had to be 1-to-1, which meant it had to pass a horizontal line test. And the sine function does not pass a horizontal line test. So in order to make it have an inverse, what we have to do is restrict it. Now, if we restricted it from 0 to pi, it still wouldn't pass the horizontal line test. In order to restrict it so that it has all possible values of y and the values of x that would restrict it to cover all those, we're going to restrict it from negative pi over 2 to pi over 2. And when we do that, and we talk about just this little piece, then the sine graph has an inverse because it's now 1-to-1. So its inverse will take and flip those x and y values. All right? So I'm going to do that on the slide that has your notes. This is the one I was talking about. It says, because angles and arcs given on the unit circle have equivalent radian measures, the inverse sine is sometimes also called the arc sine. Okay, so it means the same thing. So when you see this, okay, make sure you understand this, that they're the same thing. All right, so this is what you have on your notes. So I want what I want you to do is I want you to realize that we're going to get rid of all this. And we're only going to keep this piece that went from negative pi over 2, negative 1, to positive pi over 2, 1. And we're going to get rid of all the rest of this. And then that little piece, when we do its inverse, the inverse function will look like... Your ears were not broken by the barking dogs. I have a really hard time editing the videos, so I just stopped it quick, but somebody probably had their eardrums blown out. Sorry. So what happens when we do the inverse is that the x and y ordered pairs reverse. So this becomes -1, negative pi over 2. And this ordered pair becomes 1 pi over 2. And then the shape, remember the inverse means it's going, it's the reflection of this, so it ends up going like this. Okay, we'll see if I did that right. We'll go look at the other one, but I'm not going to ask you to graph these. Let's see. Yes, this is what it's supposed to look like, okay? So I think I have the right shape going. All right, I'm not going to ask you to graph these. I'm just trying to help you to understand why it is restricted and why it doesn't go on forever, okay? So we have restricted it to this little piece right here, and then we did its inverse, so it ended up going this way. Okay. Now, I'm going to explain how this works, but we're going to use a unit circle for this eventually. This question is asking what angle, okay, what angle has a sine value, which would be back here, of square root of 3 over 2. So that means the y value is bigger than the x. So it happens up here at pi over 3 or 60 degrees, and that's going to be the answer to this question. But we're going to use a unit circle to find it. This question is asking what angle has a sine value of -2 pi, or -6.28. Well, I want you to think about that for a minute. Here's a sine graph. It went from 1 to -1. Now we're doing an inverse sine, but we're doing it backwards, so we're trying to figure out what is the angle. Are there any angles that have a sine? No, the sine never goes above 1 or below -1, so this is not possible. They like to ask those kind all the time. All right, this is asking where is the sine -1? Now there were places where it hit -1 over here, okay? But remember that the inverse sine is restricted to this little section right here. So we want to remember that it hit -1 over here at -pi over 2. And it's going to be easier to remember when I show you the new colored unit circle. All right. I just want to get through inverse cosine and inverse tangent, and then we'll color the unit circle. All right, so remember cosine looked like this. Its max was on the y-axis. So this time we can't restrict things between -pi over 2 and pi over 2 because we would just get this little piece in here and it still wouldn't be 1 to 1. So the restrictions for cosine are a little different. We're going to restrict it from here, which is 0, to pi. So the ordered pairs here, well, let's do it on the notes that you have, okay? You have this. We're going to restrict it from here to here. This is the only piece we're going to take when we go to do the inverse. So the ordered pair here was across 0 and up 1. And over here, this was over pi and down at -1. So when we take and do an inverse of that, you have over 0 and up 1. I'm sorry, we're doing the inverse. So it's over 1 and up 0. And then we had pi, -1, the inverse means we're flipping those, so we'd have -1, and it would be up at pi. And then if we flipped that across, it's actually going this way. So I think I have that drawn right. Let's see, because I always have trouble with these. Okay, there it is. -1 pi, pi. Okay, it's not very good. All right, anyway, like I said, we're not going to worry about the graphs of these very much, but what you need to remember is it went from 0 to pi. So when we start talking about the unit circle, 0 to pi is going to be quadrants 1 and 2, which is what this slide shows us, okay? That when we have restricted this from 0 to pi, we can only look up here. All right, so looking in those two quadrants, let's see, there's a negative square root of 3 over 2 in the x spot. If I went over here, that would be up only 1/2, so up 30, so 150. That'd be 5 pi over 6, okay? And we're going to use a unit circle that has these already drawn on it. This is, where is the cosine 2.5? Again, think about the cosine graph. The cosine graph, the regular cosine graph, never goes above 1 or below -1. So this is not possible. Where is the cosine -1/2? Well, that would be when you went left just a 1/2 a unit, which would actually be a 60 down here, which would be at 120 or 2 pi over 3. All right, and that'll make more sense when we can just look on a unit circle and find it. All right, now, last one, tangent. The tangent graph has kind of natural restrictions. If we just use these asymptotes, then that little piece will be 1 to 1. Okay, the thing we have to remember is that when we say it goes from -pi over 2 to pi over 2, it's no longer inclusive. It does not include those because they're asymptotes. And then we're going to flip it and go the other way. So we are going to concentrate on this piece right here. We don't really have ordered pairs to flip around. We could find a couple, but the bottom line is that -pi over 2 was an asymptote, is now going to be a horizontal asymptote. And +pi over 2 is going to be a horizontal asymptote this way. And then it's going to flip and go this way. Okay. Again, I'm not going to ask you to graph these. I'm going to ask you to evaluate where they happen. And what you need out of that then is that this goes between -pi over 2 and pi over 2, which on our unit circle, pi over 2 is this way, 90, and -pi over 2 is this way, 90. So we are looking in quadrants 1 and 4. So here is where we're looking for quadrants 1 and 4. But the problem is the tangent is not anywhere on our unit circle. To find the tangent, we have to do y over x. We have to take all the ordered pairs and put the y over the x. So I'm going to talk you through a couple, and then we're going to practice. I'm going to do this one first, because this one's pretty easy. Remember we just said these two quadrants, here and here. The tangent is 1 when you have this ordered pair, because you put that y over that x and you get a tangent of 1. Okay, and that would happen at pi over 4. To make it -1, we're down here, went over square root of 2 over 2 and down square root of 2 over 2. So when we put the y over the x at negative pi over 4, we get a tangent of -1. Now, couple things about that. I can't call that 7 pi over 4, even though that's where it is on the unit circle. This doesn't work because the restrictions were between negative pi over 2 and positive pi over 2. So you have to call these by a negative answer, negative name, and we're going to do that and renumber our unit circle. All right, last one that's tricky. This one is really tricky. Nowhere down here is there anything that's going to tell us the tangent is this. If I wrote these down real fast, I would have right square root of 3 over 2 down a half, right square root of 2 over 2 and down square root of 2 over 2, and right 1/2 and down square root of 3 over 2. So it has to be at one of these that has a square root of 3. The issue is if I do the tangent here and put the y over the x, or the y over the x here, or the y over the x here, this is just going to be negative square root of 3. This one was negative square root of 2 over square root of 2, which is just -1. This is the one that rationalizes and becomes negative square root of 3 over 3. So it's this spot that I need to find, and that is a 30-degree angle or a negative pi over 6. All right, now those were just me doing them out of my head, but we're going to do them by using a unit circle. I gave you this slide on your notes because in a normal year, I would only give you this on an actual test, and you would have to use this information right here to restrict the sine, cosine, and tangent and answer off a regular unit circle. Now this year's unique, so you're going to get to use your notes. So it's going to say on your notes here that the sine or arcsine is, now I want to color this. I did this in a, okay, yes, I did do purple. Okay, I'm going to do purple, and it is going to be from pi over 2 up here all the way down to negative pi over 2 down here. Okay, however you want to color that. Wouldn't make it too big because we're going to have to write some other stuff in here. You can decide how to color it. Okay, but what we have to remember is we cannot call these what they are normally called. 5 pi over 3, 7 pi over 4, and 11 pi over 6. We have to rename them, and we just use symmetry. If this was up pi over 6, this one is down pi over 6. If this one was up pi over 4, this is down pi over 4, negative pi over 4. And up here at 60, we went up pi over 3, so this one is down pi over 3. And this would be down, or in the negative direction, pi over 2 to get to this one, okay? So those are the names of these in negative radians. So if we had a sine, like it said, where is the sine -1/2? You'd look at the y coordinate, because remember the coordinates go cosine and sine. So the sine is -1/2 at negative pi over 6. All right. The cosine, remember the cosine, I'm going to do in red here, the cosine is restricted from 0 around to pi. So that's all of this. We can use answers that go from 0 around this way to pi. All right. So we can use 0, pi over 6, pi over 4, all of these. We're going to answer in radians, so we can go all the way up to pi. Now arctangent, remember, was negative pi over 2 to positive pi over 2. So I'm going to go ahead and color it purple because it's the same two quadrants. But remember, maybe I'll do, I don't know here, green or something. The tangent is y over x. So 1 over 0 is undefined. So you cannot find the tangent here at pi over 2. So it ends before you get there, okay? The tangent here is square root of 3 over 1. The tangent here is square root of 2 over square root of 2, or 1. These are tangents now, okay? The tangent here is 1 over square root of 3, which becomes square root of 3 over 3. Just keeping this in mind. You really shouldn't have to write them down. You should be able to do them in your head. Here, y over x, 0 over 1 is 0, so the tangent here is 0. Whoa, messed up. Hang on. Undo. All right, when we get down here, at negative pi over 6, the tangent is negative 1 over square root of 3, which would become negative square root of 3 over 3 when we rationalized it. The tangent here is negative square root of 2 over square root of 2, which would be negative 1. The tangent here is negative square root of 3 over 1, or just negative square root of 3, and here the tangent's undefined, so we can't use it. All right, so those green numbers I wrote out there were the tangents at each of those points. So now the questions become really easy when we use that to look at. So this is saying, where is the sign negative 1/2? Well, we go, sine on my graph is purple, so I have to be in one of these two quadrants. And the sine goes cosine, sine. So the cosine would be in, I'm sorry, was it a cosine or sine? I lost my train of thought. This was a sine. Where's the sine negative 1/2? And that happens right here. So we write down negative pi over 6, because remember, we can't call it 11 pi over 6 because it doesn't fall in the range of values that's allowed. Number 2 says, where's the cosine for? Cosine cannot be more than 1 or less than negative 1, so this is not possible. We're going to learn that there can be things that are not on the unit circle, but they can't be above 1 or below negative 1. All right, where's the tangent 0? Now, normally you would have to go around and think, well, let's see, 1 over 0, that doesn't work, this doesn't work, this doesn't work. But I actually wrote them down. 0 over 1 is 0, and the angle there is 0 radians. Okay. Up here we have, where's the tangent negative 1? Tangent, again, was purple, so we're looking in these two quadrants. The tangent is negative 1, right down here, and that's at negative pi over 4. Where's the sine? Negative square root of 3 over 2. Sine, remember, is y value, so that happens down here, and it's at negative pi over 3. Where's the sine negative 2? Okay. This is not a reciprocal function, okay? We're not flipping it over. It asks for an actual sine value of negative 2, and the sine can't be more than 1 or less than negative 1. And this is below negative 1, doesn't work, it's not possible. Okay, inverse functions are not reciprocal functions. I should have stressed that earlier in the lesson. All right, we have a few more here. Where is the sine square root of 3 over 2? Positive, that would happen right here, which is at pi over 3. Where is the cosine square root of 2 over 2? That is happening here at pi over 4. Where is the tangent? Negative square root of 3 over 3. Well, before that was flipped over, it was this. Okay, Before it was rationalized, I should say. Before it was rationalized, it was this. So we need a y value of 1 and an x value of square root of 3, and it needs to be negative. So negative 1 over square root of 3 right here at negative pi over 6. All right, for the first time, I think, we have a cosine that's negative. Cosine, remember, was the red. And I just did this one real fast because it was in the first quadrant. It was a pi over 2 here. But this is saying, where's the cosine? Negative 1/2. If I only look in quadrants 1 and 4, the x's are all positive, so it won't work. For cosine, I have to look in quadrants 1 and 2, and it happens here, so the answer is 2 pi over 3, which works because it's a cosine function. All right, one more little piece to this lesson. Remember, when we did inverses, they were functions that undid each other. And if you took the composite of a function with its inverse, they undid each other and got back to the beginning, or the x value. But that does not always apply when you're doing inverse trig functions. Okay, you have to take them slowly and think your way through it here. This is when it does happen, but I don't want to memorize all this, okay? It says, because the domains of trig functions are restricted in order to obtain inverse trig functions, the composition of a trig function and its inverse trig function does not always undo each other. All right, they will undo each other if the inverse sign is inside and the x is less between negative 1 and 1. They will undo each other if the inverse sign is on the outside and the values are in the right quadrant. Okay, I don't even think about this. I just find the value, work my way inside out, and decide then if it has undone each other or not. And honestly, they will trick you because they don't always use even the same function. And I'll tell you what I'm talking about in just a second. Look at this one. This has a cosine and a sine, so of course they don't undo each other. I'm going to leave number 11. 11 is an intro to what we're going to do tomorrow. Okay? I'm going to start with number 12. It says, what is the cosine at pi over 2? Well, you go to pi over 2 and you find the cosine, which is 0. And then it says, where is there an angle whose cosine is 0? Well, if you look, cosine has to be in these two quadrants, and the x is 0 here, so the answer is just pi over 2. So indeed, these undid each other, the inverse cosine and cosine, and you just wound up with pi over 2. But it doesn't always work, so I would highly suggest that you just, do it from the inside out. For example, this one says, what is the tangent at 3 pi over 2? If I go to 3 pi over 2 down here, well, first of all, it's not an answer we can pick with an inverse. But if I go down here, the tangent is negative 1 over 0, because it's always y over x. So this is undefined. And you can't do an inverse of undefined. So this is not possible. Okay? And this one isn't even the same function. It has cosine in here, so you're to find where what is the cosine at pi over 6. So pi over 6 is here, and its cosine is here, so this is negative or positive square root of 3 over 2. And then it says, where is the sine? Remember, when it's an inverse, it's where. Where is the sine? Square root of 3 over 2. And that happens up here, the sine, the y value is square root of 3 over 2, and that happens at pi over 3. Right, I'm coming back to 11. I won't forget. Did we skip some? No, that was 14. Okay, number 15. These aren't the same function even. This says, where is the sine 1/2? And the sine or the y value is 1/2 at pi over 6. And then it says, what is the cosine of pi over 6? Well, at pi over 6, the cosine is square root of 3 over 2. So the composite wasn't even undoing each other. These aren't either. This is a sine. Where is the sine negative 1/2? Okay. The sine is negative 1/2 right down here at negative pi over 6. Now it says, what is the tangent at negative pi over 6? You can't do, oh yes you can. Inverse tangent is in these two quadrants. It doesn't matter though, because it doesn't want an inverse tangent. It just wants the straight up tangent. What is the tangent value if you go to negative pi over 6? Well, if you go to negative pi over 6, right here, the tangent is y over x, so negative 1 over square root of 3, which rationalizes, and some of you already saw it down there, it's negative square root of 3 over 3. All right, this is the trick one, because it's going backwards. The arctangent first, and it's very hard to find if you're not used to this, but this is a y over an x that looked like this, but it was negative. The inverse tangent is purple, so it's in these two quadrants. There was a y over an x that was a 1 over square root of 3, and that happened right down here at negative pi over 6. But now it wants, what is the cosine there? Well, while we were down at negative pi over 6, the cosine was the x, so it's square root of 3 over 2 is the value they're looking for. All right, do these just undo each other? They're cosine and arc cosine, but the answer is no, because this says, where is there a cosine? Where's there an angle that has a cosine of 2? The cosine can't be 2, okay? The cosine can only be between negative 1 and 1, so this is not possible. So you really have to be careful on these. All right, last thing I'm going to do is go back here. And this is the lesson we're going to do tomorrow, but inverse cosine is negative. Inverse cosine is, I'm sorry, sine, inverse sine is purple, and it's negative then in quadrant 4. If I were to draw a quadrant 4 angle whose sine, opposite over hypotenuse, was 3/4, and it had a negative, the negative would have to be on the y because it went down. And we could find any function because we could finish doing Pythagorean theorem and find the rest of this, but it just wants the sine. Well, the sine for that silly little triangle is just negative 3/4. So that's one where they just undid each other. But tomorrow we're going to have these kind where it's not on the unit circle and we have to draw the triangle. All right, so today I want you to do, for your assignment on this, some of the problems off a worksheet, okay? And it will be attached in the Google Classroom.